Hello friends, I am Professor Neha Mahurkar. I welcome you all in this video. I have prepared video on the unit Physical Properties and Molecular Structure. So in this unit we have to discuss the polar molecules, non-polar molecules, their polarization, dipole moment and magnetic susceptibility. So we will see first the molecules. You all know what is molecule, what are its properties, but we will discuss here the properties of a molecule which are based over the electronegativities. You are quite familiar with the term electronegativity. So on the basis of electronegativity difference between the two atoms, the molecules are classified into two types, polar molecule and non-polar molecule. Okay, so the polar molecule is where the distribution of electrical charge in the molecule is unsymmetrical. Here you can see that there are two poles, one is positive, one is negative. And in the example HCl, you can clearly see that Cl carries negative charge and hydrogen carries positive charge. It is just because chlorine is more electronegative than hydrogen. In the same way, we can explain HF and NH3. Fluorine will carry negative charge, hydrogen will carry positive. And in ammonia, nitrogen is more electronegative, hence it will carry negative charge and hydrogen will carry positive charge. So the next type is non-polar molecules. Again, it is classified on the basis of electronegativity. When the electronegativity difference between the two atoms is negligible, or we can say that both the atoms have same electronegativity value, then that molecule is called non-polar molecule. Okay, the examples are clearly shown here. Nitrogen molecule, oxygen molecule, hydrogen molecule. Here you can see nitrogen is triply bonded with the nitrogen. That is, both the atoms have the same electronegativity value, and that's why it is classified under non-polar molecules. Okay, then next we will see the dipole moment. So what is dipole moment? Dipole moment can be defined as the product of magnitude of charge on any one of the atoms and the distance between them. So we will see first that what it is used for. It is used to express the degree of polarity, means at what extent the molecule is polar. Means clearly it is related with again electronegativity difference. For example, let the molecule AB, where B is more electronegative than A, and you can see here that B is carrying negative charge and A is carrying positive charge, and their dipole moment is given by formula mu is equal to Q into R, where Q is charge on any one of the atom, either A or B, and R is the distance between them. This distance is R. So we will move towards the next topic, the unit of dipole moment. The dipole moment is expressed in the unit dBi. dBi, that is the dipole moment operative between the two atoms. Okay, so 1 dBi is equal to 10 raised to power minus 10 electrostatic unit into 10 raised to power minus 8 centimeter. Then we will see the SI unit of dBi. As earlier we have seen that dipole moment is calculated by the formula mu is equal to Q into R. Okay, the Q, that is charge, is expressed in terms of coulomb, and R, distance, it is expressed in terms of meter, and that's why the SI unit of dBi is coulomb coulomb meter. The SI unit of dipole moment is coulomb meter, and 1 dBi is equal to coulomb meter. Okay, the dipole moment can be determined experimentally, and it is the means it gives idea about the polarity of a molecule. As dipole moment means the polar molecule have both direction as well as magnitude, and that's why the dipole moment is a vector quantity. Now the dipole moment is represented by the arrow which started from the negative end and ends up towards the positive end. Here you can see the chlorine and hydrogen bond. As chlorine is more electronegative, therefore it will start from chlorine and it will move towards the hydrogen, that is positive end. Okay, the next, the molecules with non-zero permanent dipole moments are polar molecules. Here you can see that is polar molecules have non-zero dipole moment and non-polar molecules have zero permanent dipole moment. Next topic is induced dipole moment. Now you have idea about the term induced. Induced means which is forcefully done, or which is means the way we carry out the thing, or we push means we apply the force. So induced dipole moment means when as we have seen that polar molecule have dipole moment, we have also seen how it is calculated by using the formula mu is equal to q into r. But what about non-polar molecules? Means the non-polar molecules when placed in an electric field, they behave as a dipole. Means they behave as a dipole and they acquire dipole moment. That is, they shows the unsymmetrical charge distribution, and it clearly means the separation of the charges. One is positive and another is negative. Here you can see first the non-polar molecule is shown here without charge, and after passing through electric field, the separation of charges plus and minus, and such dipole moment which is developed after applying the electric field called as induced dipole moment. And the induced dipole moment is directly proportional to the strength of applied electric field. Next is polarization of a molecule. Here you can see that molecule is composed of positively charged nuclei as well as negatively charged electrons, and due to the balance between positive and negative charges, the molecule is completely neutral. Again the same thing we will see here. When a molecule is placed in electric field, here you can see the molecule when placed in electric field, the negatively charged electrons in a molecule, they will attract towards the positive plate, and the positively charged nucleus or the nuclei will attract towards the negative plate, and it is definitely under the influence of applied electric field, and the molecule is called as polarized, and this whole process is called as polarization. Okay, you can see here diagrammatic representation. Now we will see the types of polarization. There are two types of polarization. One is induced polarization and another is orientation polarization. Again, the induced polarization is same as we have explained earlier, that when the molecule is placed in electric field between two charged plates, one is positive, one is negative, the positive nucleus will attract toward the negative plate and the negatively charged electron will attract towards the positive plate, and the induced polarization is explained represented by the symbol Pi. Okay, the induced polarization is classified into two types. One is electric polarization represented by Pe, and one is atomic polarization represented by Pa. Now, in case of electric polarization, electrons are distorted with respect to the nuclei towards the positive plate, while in case of atomic polarization, the nuclei will be distorted with respect to each other, and the total induced polarization is given by the sum of Pe, means electric polarization, and Pa, that is atomic polarization. The next type is orientation polarization represented by the symbol P0, PO. The orientation polarization can be explained like this. As we know that each polar molecule possesses both positive as well as negative end. But what in case of uh, when there is no electric field, that is in the absence of electric field, the molecule behaves randomly, means it will be oriented in all the possible directions, and it is only due to the thermal effect. I will explain it with the help of one diagram here. The first figure which I have highlighted as random, it is absence of the electric field, and you can see here the polar molecule, that is plus and minus charges are developed here. It is oriented in all the possible directions. So then in case of applied electric field, here you can see induced, that is when the polar molecules are placed in electric field, they will show induced polarization, and after that the electric field tends to orient the molecule in the direction of the field as they are polar. But what happens when the molecules are in constant motion, and that motion is called as thermal motion or the thermal effect? Due to the thermal effect or the thermal motion, what happens? The thermal motion opposes the orientation, and the molecule would occupy the mean position between the direction of the field and their original position. Here you can clearly see the molecules are occupying the in between position, the mean position, and this effect is called as orientation polarization. That is, the orientation polarization can be defined as the effect of electric field on polar molecule to occupy the mean position between the direction of the field and their original position. And the orientation polarization is given by the formula. Here you can see where mu is dipole moment, then K is Boltzmann constant, T is temperature, P0, PO is molar orientation polarization, and Na is Avogadro's number. Okay. The next and the last in this video, I will explain the concept of molar polarization. Molar polarization is the sum of induced polarization Pi and orientation polarization Po. Now the induced polarization is independent of the temperature, but orientation polarization totally depends upon the temperature, that is it will change along with the temperature. For example, O2, CO2, N2, H2, all these are non-polar molecules. Their molar polarization do not changes with temperature. Okay, means it is independent of the temperature, and that's why they do not show orientation polarization. And in case of HCl, CH3Cl, means in case of dipole, the the molar polarization changes along with the temperature, and hence it will show orientation polarization as they possess permanent dipole moment, HCl, CH3Cl, as I have explained earlier. So with this last concept, I conclude my video, and the remaining I will try to complete in the next video. Okay, if you have any difficulty, feel free to ask. Okay, and go through the book. I hope everyone have the means the Octa book, chemistry book, and go through this. If you face any difficulty, please ask. We will discuss over it. Okay, the remaining chapter I will try to complete in the next video.